Creating realistic game physics involves integrating principles from physics into virtual environments to simulate natural behaviors and interactions. Here are steps to achieve realistic game physics. Understand physics principles. Familiarize yourself with basic physics principles such as gravity, friction, inertia, and collision dynamics. Understanding these concepts is crucial for accurately simulating real-world interactions in your game. Choose the right physics engine. Select a physics engine that aligns with your game's requirements. Popular physics engines like Box 2D, PhysX, used in Unity and Unreal Engine, and Bullet Physics offer robust features for simulating realistic physics interactions. Implement collision detection. Implement accurate collision detection algorithms to detect when game objects come into contact with each other. This is essential for ensuring objects interact realistically based on their shapes and properties. Set up rigid bodies and constraints. Define rigid bodies for game objects that need to interact physically. Rigid bodies simulate objects with mass, allowing them to respond to forces like gravity and collisions. Use constraints, such as joints and hinges, to simulate connections between objects realistically. Apply forces and impulses. Use forces, like gravity, applied forces, and torques, and impulses to simulate how objects move and interact in response to player actions or environmental changes. Adjust these forces based on object properties like mass and velocity for realistic movement. Simulate friction and restitution. Incorporate friction to determine how objects slide against each other or stick to surfaces. Restitution, bounce, controls how objects react to collisions, affecting how much energy is transferred during impacts. Fine-tune parameters. Experiment with physics engine parameters such as gravity strength, collision shapes, and material properties to achieve the desired level of realism and gameplay feel. Fine-tuning these parameters is crucial for balancing realism with game performance and playability. Handle special cases. Address special cases like vehicle physics, fluid dynamics, and complex object interactions. Implement specialized algorithms or physics behaviors to simulate these scenarios realistically within your game environment. Test and iterate. Test your game physics extensively through gameplay testing and simulation scenarios. Gather feedback to identify and address issues like glitches, unrealistic behaviors, or performance bottlenecks. Iterate on your physics implementation to improve accuracy and player immersion. Optimize for performance. Optimize your physics simulation to ensure smooth gameplay performance across different platforms and devices. Consider techniques like spatial partitioning, collision culling, and physics simplification to maintain a consistent frame rate and responsiveness. By following these steps and leveraging the capabilities of modern physics engines, game developers can create immersive and realistic physics simulations that enhance gameplay and provide a more engaging player experience.